Hello, everyone. Welcome to the Math Magician's Den. We are going to talk about taking derivatives of either exponentials or logarithms here today that involve a base that's other than e. Now, we know that the derivative, if you take the derivative with respect to x of e to the x, we know that's e to the x. And in a previous video, I explained how the derivative of a to the x was a to the x times the natural log of a. And if you have a to a function, the derivative is a to that function times the derivative of the function times the natural log of a. So what we're doing here is we're multiplying by the natural log of the base. Well, when it comes to logarithms, we end up taking division by the natural log of the base. The derivative of the natural log of x is 1 over x. But the derivative of a logarithm that has a different base, you have to divide by the natural log of a. And you're probably thinking to yourself, well, why would I have to do that? Well, here's the thing. When you take the derivative of log base a of x, that's the same as taking the derivative of, change of base formula would be the natural log of x over the natural log of a. And you'll notice that natural log of a already on the bottom, that's a constant. And the derivative of the natural log of x would be 1 over x. And hopefully it makes sense, because if you're multiplying by the natural log of the base here, you should be dividing by the natural log of the base here and vice versa, because exponentials and logarithms are inverses. So their derivatives, the inverse part of their derivative should be the same. Okay? So when you take the derivative of the log base a of a function, you would put the derivative of the function on the top, you would put the function on the bottom, and you would divide by that natural log of a. Okay? So let's try a few problems here that involve logarithms with bases other than e. So how would I do log base 3 of x to the fourth? Well, here's the thing. Normally what I would say is the derivative of y with respect to x, you would put the derivative on the top, which is 4x cubed. You would put the function on the bottom, which is x to the fourth. That's what you'd write if it was a natural log. But here what we're saying, if it's log base 3, you would have to divide by the natural log of 3. And this does simplify to 4 over x natural log of 3. That would be my derivative. Now think about it. If I had brought the 4 out front, this would have been written as 4 log base 3 of x. And if I took the derivative of that, I'd have the 4 times 1 over x, and I would divide by the natural log of 3. So I'd end up getting the same thing if I expand it. Certainly this next one will make sense, because all you have to do is take the derivative. Y prime would be the derivative of x cubed minus 3x would be 3x squared minus 3. On the bottom, you would put the function x cubed minus 3x. I would stop here if this was a natural log. But since this is a logarithm with a base 5, I have to divide by the natural log of 5, or multiply on the bottom by the natural log of 5. Now, we've discussed this before with logarithms. Wouldn't it be easier if I expanded first? For example, f of x here, I can expand this into log base 4 of 16 plus 5 log base 4 of x minus 1/3 log base 4 of x cubed plus 5. The plus because they're multiplied on the top, the minus because it's multiplied on the bottom, or divided. The exponents are brought out front. Now, how do I take the derivative of all of this? Well, what is f prime of x? Well, this right here, I hate to say it, 4 to the second power is 16, so that actually equals 2. That's a constant. The derivative of a constant is just 0, so it's not going to have a derivative here. It's just going to be 0. I'm not going to write that. The derivative of 5, log base 4 of x, normally with a logarithm, I would put 5 times 1 over x. But this is base 4, so I'm going to divide by the natural log of 4 on that term. Minus 1/3 times, put the derivative on the top, which is 3x squared, put the function on the bottom, which is x cubed plus 5. And since this has a base other than e, I'm going to divide by the natural log of 4. So the derivative here is 5 over x, natural log of 4, minus the 3's cancel, and I get x squared over x cubed plus 5, all times the natural log of 4. So you notice we're doing the same thing we were doing with natural logarithms, except now I have to divide by the natural log of the base. So let's do some more here. Get some different colors going. Again, what I'm going to do here for y is I'm going to expand this logarithm. I'm going to put log of 100 plus 5 log of x plus 7. I'm going to expand that logarithm first. Now, log, what's the base here? If you don't see a base, what is it? The base is 10. So again, this logarithm here, well, even if I didn't know, if that was log of 99, it's still a constant, but that equals 2 right there. This actually equals 2, and the derivative of 2 is 0. So y prime equals 0 plus 5 over x plus 7 times natural log of 10. Now you don't see a base, but there is a base. It is 10, so we have to divide by the natural log of 10. And we're going to keep going here. And again, I'm going to stick with our methods of expanding first. If I expand this, this is going to be log base 2 of 17 plus log base 2 of x squared minus 9. If I want to find f prime of x here, the derivative of log base 2 of 17 is 0 because it has no x. It's a constant. The derivative of log base 2 of x squared minus 9 would be 2x over x squared minus 9, and I'd have to multiply by the natural log of 2 on the bottom there is my derivative. Now, anybody watching this video, I'm not sure if you would have seen it, but that logarithm up here, this is log base 2 of 17, but this is log base 2 of x minus 3 plus log base 2 of x plus 3. So when I did the derivative here, I could have done essentially 1 over x minus 3 natural log of 2 plus 1 over x plus 3 natural log of 2. That would have been an acceptable answer because this does expand into both of those logarithms. You notice I didn't need to do that. Okay? I hope this video makes sense. I hope it helps you with logarithms that have a different base. If you like this video, please like and subscribe. I'll be posting more videos later.